Good morning, everybody. It is still morning. Actually, it's exactly noon, so good afternoon. Hi, I'm Bob. Apparently, this is my Tinder profile picture. I work for Splunk. I just started at Splunk last December. I work on the observability team for the new cloud platform. A little bit closer. Is that good? Right? All right. All right, sounds good. All right. So I work on the observability team for Splunk's new cloud offering. It's a multi-tenant SaaS-based version of Splunk. I've been working in data systems for about 20 years. I worked at FreshTracks before this, and a long time Rally software person. So I live in Colorado. I enjoy all things outdoors, fly fishing. I have 2 kids, 2 teenagers, and I like beer a lot. So Tom's talk yesterday about talking about coding on a plane. It's kind of funny that being 5'17" and having a wingspan like this, I kind of wish I was a T-Rex some days so that I could actually write code on a plane. It just doesn't work out well for me. So raise your hands if you are running Kubernetes today. Keep your hands up, your T-Rex hands up, if you are running Kubernetes in production. That's just about everybody. All right. So everybody who's running Kubernetes is doing so in production. Good. So I'm sure that you are aware, I hope that you are aware, that Kubernetes emits an enormous amount of metrics. So for a moderate-sized Kubernetes clusters, 10 nodes, 160 containers, puts out more than 275,000 unique series. So this is an enormous amount of data to be able to understand what do I do with all this data. So I install all of this stuff, and now I've got all this data, and how do I reason about it? How do I get interesting insights out of it? What are the important metrics? So there's a couple of ways, and there's some repeating themes that are coming through from these talks today. There are a few ways that people have done some deep thinking about how it is that you first approach metrics in trying to understand your metric systems. The Google SRE book is a great example of the 4 golden signals. If you're only going to look at something, if you're only going to look at 4 metrics, these are the 4 metrics that you want to look at: your latency, your errors, your traffic, your saturation. The first time I saw this, I was like, oh, perfect. Now I can go start building my dashboards about all the things because I've got a framework to be able to do this. And I got to saturation on a Kafka topic and went, huh? How does that work? And so I needed to do some more research. So Brendan Gregg came up with coined a method called the use method. And he says you apply the use method to resources. And he defines a resource as typically a hardware component. So a node, a disk, some sort of bus that's on your node. So it's a physical hardware thingy. And it's utilization, saturation, and errors. So these are 3 of the 4 golden signals as applied to your resources. And I think this is a really handy way to think about resources. But what about the software that we're running? So our friend Tom here has coined the term the red method, as we've seen also today. So the red method, rate, errors, and duration, again, a subset of the 4 golden signals from Google, talk about your services. What is the rate of the request? How many errors are you generating? And what is the duration of the requests that are coming through your services? So these are great frameworks to look at your Kubernetes metrics because Kubernetes has both. Kubernetes has metrics about resources, and Kubernetes has resources about services. So let's take, with that frame of mind, a little tour of all the places where you can get your metrics out of a Kubernetes cluster. So the first thing that you're going to want to do, we're going to start from the bottom and work our way up, is install the most excellent package, the node exporter. I'm surprised that this is not installed by default on all Kubernetes clusters, but it's easily installable with things like the Prometheus Operator. So the node exporter installs as a daemon set on all of the nodes on your cluster, and it basically exposes everything that's in the proc file system as a Prometheus formatted metric. There is a ton of information that comes out of this thing: load average, CPU, memory disk. There's about 1,000 unique series that come out of a given standard Linux node when you install the node exporter. So if we apply the use method to the node exporter metrics, these are the metrics that you're typically going to start to look at. So node CPU seconds, how many seconds of CPU time am I using for utilization of your CPU? The load average normalized by the number of CPUs that you have on your machine or the number of CPUs that you have in your cluster is a really interesting graph to look at for utilization over time. Memory, disk I/O, disk usage. Unfortunately, much of what's exposed for errors on some of these things is not typically there. If you've got a CPU error on your machine, chances are your machine's not up. So there's not a lot there to monitor. So we can take a look at some of these. Let's big in some of this. Maybe get a reload on here. So if we take a look at some of these metrics on a typical Kubernetes cluster, so this is one of our clusters that's running in production. So I've got CPU utilization, CPU saturation that's running, memory utilization, memory saturation. So it's a very interesting way to look at these, to use the use method for these metrics. And you can even stack these for all of the nodes in your cluster. So this is a fantastic way to be able to look at your node level metrics. All right, so working up the stack from your node level metrics, the next step on the path is your container level metrics. Container level metrics are gathered from a project from Google called cAdvisor. The cAdvisor code is embedded inside of the kubelet. The kubelet is the thing that runs on every node that controls all of the containers on your nodes. And cAdvisor goes and gathers all of the performance information from all of your containers. So you get CPU usage metrics. You also get the amount of time your CPU is being throttled. So if you've set up requests and limits on your containers, if your CPUs are being throttled, that's something you're going to want to know. File system, read writes, any limits on your file systems, memory usage, network. Here are some examples, again, because a container is a resource, the use method would apply in these cases. So I've got container CPU seconds total, so the usage of the amount of CPU that this container is using. You should be able to sum that up, and that would equal the number of CPU seconds that you're using on your node. You can also take a look at whether or not you're being throttled from both a CPU and a memory standpoint, depending on whether or not you've set up requests and limits. So the typical memory usage metric for utilization tends to be container memory usage bytes. Now, memory usage on a Linux machine is kind of finicky because a lot of the accounting of memory gets assigned to the file system page cache. So this metric, which is actually installed in most of the sort of standard memory usage dashboards for containers, talks about container memory usage bytes. If you're worried about your container being killed by the out of memory, the killer, so if you've set a resource limit to say I've got this much memory can only be used, and the killer comes by and kills your container, it's not looking at this metric. It's looking at the resident set size metric. So that's something to definitely be aware of, and there's a lot of nuance that's in there. So if we take a look at some of these dashboards for container level metrics, come on, you could do it. So here is in our running Prometheus with Thanos. So we've got CPU usage, and we can see the CPU usage seconds, the requests and limits that are set for any given container that's running in there. What's so funny? All right. And likewise for memory, to be able to bring up all of these metrics for memory. One of the other things that we've done, of course, the graphs aren't going to reload for me, is we've put together some visualizations inside of our Grafana graphs for workloads, so a collection of like containers. So I have all of my Prometheus containers that I can look at as a single view across the entire cluster and understand what the workload of all of the like pods are for that particular workload. So, Also included within your Kubernetes cluster is the control plane. So the API servers. The API server is responsible for taking in all of the requests to control your Kubernetes cluster. Spin up pods, create daemon sets, do all of the control that you have. The API server is a server. It's a service. And it gives you all the information that you need in order to be able to look at the metrics. So because it's a service, you want to take a look at the red metrics for the API server. So you have your API server request count, the number of errors that are being produced by that request count, and then the latency of those particular requests. More source of information. So kube-state-metrics, this is another add-on package that you want to add into your Kubernetes cluster, much like the node exporter. So kube-state-metrics is kind of it's neither a resource nor a service. It exposes a bunch of state information about your Kubernetes clusters. So it gives you counts for all of the object types that are in your cluster. So the number of containers, the number of pods, the number of namespaces that you have. It exposes through a set of Prometheus metrics the container resources and limits, or your limits and requests for all of your resources, all of your container states, whether they're running, starting, terminating, waiting. And the most interesting thing that kube-state-metrics does is exposes a bunch of series that expose all of your label values for everything that's in your cluster. And it exposes that through a series whose value on that label or on that series is constantly 1. And you're like, well, why do I need a series that has nothing but 1 in it? This allows you to take that series and do a label join with other metrics in your system so that you can add additional labels to your series without having to embed those values into your code or into wherever it is that you collect your metrics. So you can actually join metadata from the system with your metrics at runtime and bring those two things together. It's a really powerful thing. etcd exposes all kinds of great metrics. Depending on where it is and how you run your Kubernetes cluster, you may or may not have access to your etcd cluster to be able to pull these things out. etcd is the master of truth for everything that's inside of your cluster. Things that you may want to be looking at is leader existence and whether or not the leader is changing a bunch. How many etcd proposals are being committed? What is your disk write performance on etcd? Because the performance of etcd is directly tied to the performance of the underlying disk file system. That's something that you're going to want to know. Again, etcd is a service. One way to start looking at these metrics is through the red method. There are so many other sources of metrics that are exposed through Kubernetes. Scheduler metrics, Kubernetes proxy metrics, the controller metrics. If you run Istio, there's a wealth of information that comes in from Istio. With all of these metrics that you have out here, you don't want to be doing all of this by hand. So as we've already seen referenced today, the Prometheus operator is an excellent way to get started running Prometheus inside of your Kubernetes cluster. I can have Prometheus Operator up and running on Minikube in my laptop in about 5 minutes, applies all the things, gives me the Prometheus, gives me Alert Manager, gives me Grafana. Everything's up running with a custom set of resource definitions, as we saw earlier from Scott. The next step that you're going to want to do is have packaged alerting tooling. So as Brandon was saying yesterday, all of these packages that we are using should come with all of this monitoring stuff out of the box. It should just be there for us. So the monitoring mixins project, of which Tom has helped put together, brings together a set of packaged monitoring configurations for both recording rules for Prometheus, dashboards for Grafana, and alerting rules for Prometheus as well. All of that written in JSONet. JSONet allows you to take those configurations and tailor them exactly to your environment without having to mess around with misnamed data sources for community dashboards that you may download for Grafana. These monitoring mixins today are already available out of the box for Kubernetes, etcd, Console, and Vault. And they're community maintained. So we have put a couple of pull requests up for the Kubernetes monitoring mixins that adds multi-cluster capability. So I can actually look across a Thanos configuration with many clusters and see multiple clusters at once. The workload dashboard that I showed earlier was a contribution that we put up and allow you to break down your pods by workload. community maintain is a really big deal, especially in the face of when your metrics change. So coming in Kubernetes 1.14 and 1.15, there's going to be a bunch of metrics that are going to get renamed, labels that are going to change. This is in an effort to clean up all of the metrics that are being exposed inside of Kubernetes. If you have dashboards today that you've written by hand against these metrics, they are going to break. So now is the time to start using something like the mix-in project in order to take those dashboards, because the mix-ins will be fixed along with the metrics that are coming along. That's all I have today. Thank you so much.
Thank you very much, Bob. I really enjoyed that. Thank you.
Yeah.
So who's got questions for Bob? Put them on the channel. Let's see what we've got. So the first question I had was kind of the same as I gave to the previous speaker. What could we do in Grafana to make this whole thing easier and better?
Yeah, a couple things. And you and I talked about this yesterday. So the mix-in pattern that, especially for Kubernetes, basically stops at here's a set of YAML or JSON or whatever the target is for where the data is going, and it's up to you to figure out how to get it into your system. Putting those things into folders is definitely a big sort of a big pain point, because it would be nice to be able to define from the outside, this is a folder of dashboards, automatically folder those up. So that would be one. And then better runtime tooling in order to get dashboards into a running Grafana would be
definitely
great.
Yeah. We've actually started the monitoring mix-ins GitHub org, and there's a project in there by Matthias. I've forgotten his second name. Metal Matze. I've forgotten. Yeah, called Mixtool, which is designed to do exactly this.
Oh, very cool. Yeah, nice.
And it's designed to help compile the mix-ins into the raw, the YAMLs, and upload them and solve that kind of problem. And funnily enough, the first issue open in that repo is how do we do folders?
How do you do folders? Yep.
So like PRs are welcome, man.
Okay, perfect.
So the next question I had before I move on to audience questions, sorry. This is like a great privilege I get, is to give the first questions. What would you say is the kind of top 3 kind of alerts or kind of insights into Kubernetes that people might not know about? Like, what are your most useful Kubernetes alerts?
So you want to keep track of your control plane. So as I talked about earlier, keeping track of the etcd metrics if you are responsible for managing your etcd, because if etcd is out, then your whole cluster is down. So your disk throughputs for etcd leader election. Requests and limits. If you should be setting requests and limits on your containers, and so if you're if you are requesting that your developers are setting requests and limits on your containers, people are going to look at that and go, I don't know, we'll put it right about there. And maybe that's too high, and maybe that's too low. If they've set it too low and you're getting throttled, you have bad performance and you don't know about it. So being able to look at how the container is interacting with the Linux scheduler is definitely a big thing. Overall, memory. If you're oversubscribing your cluster for memory, so keeping track of how much memory you've got going on your cluster is also a very big thing to put your alerts on.
Cool, thank you, Bob. So we've got a question from Bob, another Bob,
Another Bob.
2 Bobs. With the scale of Splunk, you most likely see some really neat failure cases, let's say, that we probably haven't seen yet. So what would you say kind of is the most extravagant or most interesting way you've had Kubernetes break? And how did you find out about it?
Yeah, so so I'm brand new at Splunk, so I've only been there a few months, so I don't have a lot of deep insight into this. And the product that we're doing the visibility for is still nascent. So there's a handful of beta users that are on it. So we don't actually have the grand scale that we are about to have on this. So those days are coming, and next year I will come back with some scars and some battle stories.
Cool, cool. There's a lot of people saying that that was a really good talk and that there's loads to unpack. So will you be putting the slides somewhere for us to?
Yeah, absolutely. I'll put this up on Speaker Deck. Do we have any way to do this as part of the Grafana website?
We'll do something. Yeah.
Okay.
I have no
yeah.
idea.
Wherever those are. Otherwise, I'll drop the link in the channel.
Cool, excellent. So my final question, you've talked about the use method, you've talked about the red method, and you've talked about the 4 golden signals. Why is the red method better than all of the other ones?
Because you wrote it, of course. No, I think they each have their place, as I said. Use is for resources, red is for services. Not all 4 of the 4 golden signals applies to all of the things, and saturation being the sort of the sticky one. How do you apply saturation to a service? It just doesn't apply. So that's why.
Any more questions from anyone? We've exhausted them all on the channel. Nope, we'll stop there.
Great.
Thank you very much, Bob. Round of applause, please.